Hello, today I would like to show you how you can connect a server-grade SAS hard disk drive into your MacBook computer or Mac Mini using a Thunderbolt cable. We are going to populate this enclosure with a free drive, and we are going to try a software RAID using a SAS cabling, and we are going to see what's going to happen. First, let's understand the key difference between SAS drives and the consumer-grade SATA. The key difference on the SAS drive is that they are going to last much longer, and you can say that word much couple of times. The SAS drive was designed to be working like in a database server where you are constantly reading, writing, and that process is repeat day, night for a couple of years. So they were built to last. You as an enterprise customer, you will much likely to give more money to have a warranty that the drive is not going to fail, and you will not need to slow down your database server for a rebuild process. So you will more likely shell more money for the ability to that drive not failing under the high load, where on the consumer grade, in general, you will not be happy to pay much more money to give that lifespan, because you are not going to stress those drives. You are not going to constantly every day reading and writing for them. Most likely you will put your OS, you will be browsing your net, and that's all. Maybe you download something once for a while. So they are not designed for that extremely high stress of situation, and that is being reflected on the price. Second thing is those SAS drives are reporting much long list of parameters for the SMART, the self-monitoring system, and you can detect more pre-fail condition. So if you've got like a hardware RAID card, it can checking the SMART status, and you will see that the drive is going most likely fail before it fail. The third thing that is also very important, the SAS drive are giving you a more input-output operation per second. You can have a SAS drive that will be spinning much faster than the regular one, but even a same speed drive will give you a more input-output operation. So if you've got the database server from a first example, or you've got a web server, this drive will be better in jumping between different files and giving you much faster results. That make absolutely no difference from like a normal computer, where you are just going to copy file from one medium to your disk. You are not going to see the difference. But if you've got going to have like a RAID5 array, and you are going to be copying in that array, then a simple right click and copy paste operation will start to creating an input-output operation, because you have to calculate the parity, you have to read data, and you have to write data. So those will be faster. On synthetic benchmark, they will look very similar, because you are going to grab a bunch of zeros from a dev null, and you are going to write to them, and they will both look similar in the sequential writing. But when they will have to jump and do more input-output operation, they will be much faster. I prepare for you example of a two type of drive, the 2.5 inch, 3.5 inch, and I've got them in the SATA and the SAS version, so you can see that the form factor really doesn't care. What is important, if you take a look at them, they look exactly the same. That one is in the tray, maybe it's a little bit beefy, but this is not a problem, because the 2.5 inch also can be a more fat. The bottom is a regular SATA connector, and in the middle you've got a cutout that is separating the power from the data lines. On the SAS drive, everything is connected together, and if I'm going to flip the drive, you will see that in that space we've got additional pins. You can see we've got gold pins that are giving us additional connections. The idea is that you can plug a regular SATA drive into a SAS backplane, into the SAS connector, but you cannot plug a SAS drive into a SATA connector, and I will show you that just in a second. Same thing with a 3.5 inch. They've got the same dimension, they've got the same layout of the connector, but one of them have a cutout, another does not. And the SAS drive have additional pins. Here you can see them. Here we've got a split. Here I've got two enclosures. One of them is a SATA one. A second one is my beautiful SAS enclosure. We are going to open and remove one of the trays, and we are going to see how the backplane looks. This is the SAS connector, and it's going to accept both a SATA drive and the SAS. You've got that separation, and that's mean it's not going to fit because you've got that additional element with those connectors. So this is the physical difference. While working with a SAS equipment, you are going to most likely came across those type of plugs. They are extremely popular in the server room. I'm using them, for example, to attach the LTO drive, and they are capable of carrying 4 separate channels for a SAS or SATA. Now things are starting to be really interesting, because this cable can connect 4 hard disk drive or a different device directly to your host bus controller, which is going to be your card. It can be RAID, or it can be just a card that is going to be directly show your hard disk drive into your operating system. So this cable is going to give you a peak performance for 4 drives, and it's going to connect them directly. So your OS can write to those 4 drives at once, or it can read from those 4 drives at once. You might ask yourself what to do with that cable, and if you would like to plug 4 disks to get a direct connection with your host bus card, you can purchase adapter like this. This is a totally passive adapter. You're just changing the plug. There is no active component. You plug your cable here, and you've got an internal SAS that is carrying a 4-lane signal, and you buy that type of cable that you can stuff here, and it's going to be separated into 4. So this is how you can connect them together. So think to memorize, one of this cable can directly drive 4 drives at once. Now we have to take a look at the consumer grade counterpart of exactly the same thing, and it's called eSATA. This is how the plug looks like. This is external SATA. For eSATA, you are going to most likely need adapter. This is a Thunderbolt 2 into eSATA adapter. You plug it here, and you can connect 1 hard disk drive at that end. So the key difference is that this cable is capable of driving directly only one drive, that 4 drive. But I'm pretty sure that you are going to tell me that you've got an external enclosure like this, and that enclosure have 4 drives. And if I'm going to connect it via eSATA to computer, just like that, I'm going to see 4 drives, and I will be able to read and write from those 4 drives. And to understand this, you have to know that both SATA and SAS can allow for using expanders or SATA SAS multipliers. That means you can grab a single channel and you can divide it into like 4 channels or 5 channels. The only thing that you need to know is, does your device is supporting the SATA multiplier? That device is supporting that, so I can connect that enclosure with 4 drives via that one cable. So what's the catch? The catch is that this cable is going to be your bottleneck. The enclosure is going to have an IC that is going to be directing traffic into one of those 4 drives. So if you are going to do like RAID5 operation where you've got lots of reads and writes, in that system you are going to get a problem with the performance because your data will be waiting in queue in that cable and you cannot do more operation until the disk is going to be finishing that. So the IC is going to be routing and giving the information back and then go to the second drive. Where on the SAS cable, your host bus card can write to those 4 drives individually, and that's why it's going to be better for like a RAID5 operations where all the drives are going to be active, or even a RAID 0 operation. With this, you are going to be bottlenecked by that interface. SAS also support expanders, the port multiplying, and you've got no problem in connecting like over 100 disks via that single cable. Let's take a look at this beautiful enclosure. Everything is made of aluminum. It feels great, just like you would expect from a premium product. But thing that is interesting for us is that it's using a miniSAS connector, and that looks like a U1 power supply. How to connect our drive? We are going to grab our plug. Here you can see that you've got a pin that is sticking out and it's going to go through that slot. So this is going to be the correct way of insertion. You go like this, it nicely locks in place and it's not going to unplug by accident. To unplug it, you've got that pull tab, you're pulling it and you are releasing the plug. So this is how it looks like. So I'm pulling that and it's releasing that catch. You plug it, you unplug it. Very nice. Let's connect that enclosure. We go like this and I'm going to plug the AC. I'm not going to flip the power switch yet. Very nicely, so you will be able to see the status LED. To go from the SAS interface into your MacBook, you are going to need a HBA card, host bus adapter. You can purchase a device that looks like this, but they are very expensive. And at the end, you've got the miniSAS plug. Here you've got a Thunderbolt 2. Those pre-built solutions were pretty expensive, so I make myself one using eGPU case and a regular PCI Express HBA from ATTO. I will link to more detailed video about that construction because I'm going to showing you LTO and I'm going to show you external SATA. So we are going to take a look inside. But the idea is that you grab that plug, you connect it, then you take your Thunderbolt cable, you plug it here, you power system on. We are ready to power on my enclosure. The power is on, the drives are starting to spinning. We are ready to plug the Thunderbolt 3 cable into my MacBook. It started to charging and the disk should start appearing. Those drives should came as completely blank. And let's wait. Yes, as you can see, they are blank. They do not have any partition. We are going to hit ignore on them. And I'm going to run the SoftRAID. This is a paid software, but it have like a 14 days free trial, so you can make your testing. It will work on SATA drive and SAS, so absolutely do not be afraid. I'm pretty sure it will also work with a SSD, so give it a try. We are going start from initializing those disks. We are going to hit right click and hit initialize. They came from a Terra Master NAS. They are erasing. They are being initialized. We are going to begin our journey from creating a test. The test is going to be done with just one disk, and we are going to go with a non-RAID. I'm going to call it non-RAID, and we are going to select optimize for a digital video because that's what I'm going to be doing. The volume is creating, and we are going to use the black magic to get a synthetic benchmark. Okay, it's created, it's being mounted here as a non-RAID. It's completely empty, we've got 4 terabytes. Let's open the black magic. Let me select the drive. I'm on the non-RAID and we are going to hit a test. And you can observe that one of the drive is doing read and write operation. We've got a 130 megabytes write sequential. So as you can see, the values are not impressive, but this is our starting point. Let me create a snapshot, non-RAID, and we are going to start experimenting. So first we are going to disable the safeguard, and now we can delete our non-RAID volume. First we are going to start from something that I'm not going to be using, and this is a RAID 0, but RAID 0 should give us the best performance. This should boost everything up. RAID 0, we've got RAID 0, optimize for digital video, create. I'm going to use all the default values, I'm not going to tinker with them. And as you can see, the RAID 0 volume has been created. We've got it on the desktop. We can open it and let's repeat our black magic. We are RAID 0, open, and we are going to hit the start. And as you can see, the write performance has been boosted, not entirely 3 times. But instead of 130 megabytes, we've got almost 270, which is a significant boost. And the read performance is absolutely beautiful. We've got over 500 megabytes as a read speed, and this is pretty impressive for a spinning Rust. Sadly, I'm not going to use it, because if I'm going to lose any of this drive, my work will go bad. So I don't want to do that. Let's remove the RAID 0. Let's disable the safeguard. Let's delete our volume. Let's create a RAID5, because this is what I'm looking for, because it gives me a safety, plus I should get a performance boost on read. Optimized for digital video. I'm going to get 8 terabytes out of it, and one of those drive, any of those drive can fail at any moment, and my data will be safe. And we are going to simulate that. We are going to try that for a sake of this YouTube video. I'm going to be pulling one of those drive, and we are going to just take a look what's going to happen. The RAID5 has been created. We've got it on my desktop. Let's open the Blackmagic again. We are on the RAID5, and we hit start. So as you can see, we've got a small performance boost on the right, but not great, not terrible. But the read should be also good. Let's see what's going to be a read speed. And we've got some performance boost. That's definitely good enough for me. If I'm going to add a 4 drive, that will boost the performance a little bit more, because we've got more drives to pull the data. But I'm happy with that. I'm happy with that, because I can lose any of those drives and my data should be safe. Keep in mind that this is the synthetic test. We are just writing and reading, but we are going to do a different experiment. So let me cancel that. Let me just save snapshot, RAID5, and we are going to do something real world. I'm going to grab a video project, and I'm going to copy into that RAID array, and we are going to see how long does it going to take. This is a 23 gigabytes, and on the desktop we should see the performance. Give it a moment, and here you can see something interesting. As you can see, the data read is lower than the data write. That's because one of the drive is being used for the parity, and it's doing the calculation. So we are reading more data that we are reading. Here you can see the CPU use while copying that data into RAID5. We are idling about 45%. We're copying 23 gigabytes. So this is the impact that you are going to get using the software RAID. So as you can see, the file has been copied. In my personal opinion, that was quite quick. But now we are not going to do a synthetic test. We are going to do something more real world, and we are going to see how does it end up, because I'm planning to copy that file inside that volume, and this operation should be faster on the SAS drives, because we are going to be jumping back and forth to read the data, recalculate the parity, and store the parity. So let's see what kind of speed are we going to get on the OS level. And here you can see what we are at. We are reading 200 megabytes, we are writing over 200 megabytes. So this is the speed for something more real use case where we are copying project in the same volume. We are reading from those 3 drives. We are calculating the parity and we are writing it back to the same drive. So the head is jumping back and forth. And in my opinion, that's a pretty good value. This is going to be always much lower than just grabbing a bunch of zeros from a dev null and storing it into the disk in a sequential way. This is a real world thing. And I'm really curious what's going to happen when I'm going to remove one of those disks. But we are going to open a FinalCut because I would like to see that project. And I'm just going to take out one disk, and the SoftRAID should protect us, and everything should be working like usual. So let's take a look. Just if you would be interested, you've got no problem in putting a SAS drive into that tray. You've got a mount holes for a 2.5 inch. So as you can see, you can put both SATA and the SAS drive in that. We are almost done, and we are going to be preparing for our experiments. That's going to be the moment of truth. I've got my project being open, and we can see how does it perform. I'm jumping between a 4K video file. This is not a proxy, and it looks pretty nice. So let's take a look what's going to happen when I'm just going to remove one drive. Let's imagine that we've got one drive failing, and I will just take it out. Take a look that the LED is going to change. One drive has failed. We've got a problem. Houston, we've got a problem. One drive is failed. We've got a warning message, disk for SoftRAID volume disappear. And let's see, does my data are still there. We've got a degraded, missing disk, but it is operational. It is still operational. Let's see, does my video play? Yes, it does. It gives you absolutely no problem from those 2 drives. This is large file. We can close it, and we can, let's try to copy something into that volume just as an experiment. And as you can see, we are writing to that volume. And we can duplicate something. We can grab my project. I have to check. I don't think I've got a... Let me delete something from trash. I put my trust in that because I'm going to delete my project and I'm going to read it back. I just do not have enough room. I didn't have enough room, so I just delete my project from the hard disk drive, and now we are going to pull it back, and let's see what's going to happen. We are reading from an array that have one drive physically removed, and let's see what's going to happen. Do our data are going to be lost or not? Because as you can see, it's not. We are reading our data back, and looks like we've got a great success. We've got great success. This is a good one. This is a good one. I'm definitely going to purchase the SoftRAID. There is an interesting thing, because as I showed you here, we added a new files. We opened the video file, and the question is, does it going to be start rebuilding the array after we are plugged the disk back? So I'm going to go into the bottom shelf, the bottom enclosure. I'm going to lock it in, and it should detect the drive and start rebuilding the array. So it will be copying data from those two drives, rebuilding the parity, and we should go into the normal mode of operation. I'm pretty sure we are not going to wait for it. Yes, as you can see, SoftRAID out of sync, and it's rebuilding. It's rebuilding our drive. I've got no idea how long does it going to take. It's showing some sort of time remaining. I've got no idea why it goes so quickly. In normal hardware RAID, this is very amazing, because on a hardware RAID, when I was doing a rebuild, it was like going through a whole disk. So you would need a copy whole array. That was too fast for 4 terabytes. Something amazing happened here. So let's see. We copy back my project. Looks like it's here. The size is okay. And I remind you that we've got those couple new files that we are copying. And let's do another experiment. Let me open one of those video projects. And now we are going to make another experiment. So here is my RAID5, and we are going to do remove of different drive. So let me remove the completely different drive. Let's see, does it detect a problem? It should. Yes, we've got information that the degraded, but does it work? Let's seek to the end of the video file. And yes, it does. Let's seek through the video, and looks like everything is there. Let's make more copies of those files. Let's just copy that, paste. We are copying and pasting or a degraded array, and everything so far is looking perfect. We've got degraded, missing disk. Let's pretend that we go to the shop, we buy a new disk, we put it back, and let's see, does it going to be start rebuilding and how long does it going to take. Keep in mind that everything that we are doing here is kind of being like online. I can still hit here, play, and out of sync it's going to do the rebuilding. It's rebuilding, but I can have a FinalCut open and the video is playing. So everything is working fine. The video is playing nicely, as you can see. Let me hit play. The video is going and the RAID array is rebuilding. So that is a nice thing. Let's stop it because it should give more transfer to the rebuilding. It's rebuilding. Let's see, does it going to rebuild? Does it going to rebuild? It's working. Working. And the rebuild is completed. So looks like we've got a keeper. So as you can see, my video project was safe even when we hot unplugged the drive, we hot plug it back. That's how you can connect a a real server grade SAS drive into the MacBook computer using a single Thunderbolt cable and using the software RAID. Thank you very much for watching. I hope you enjoy it. See you next time and bye bye.